Namaskar, my dear friends. Let us try to understand how we can plot a voltage across resistor R2, that is V2, based on the variation of source voltage and one more variation of on the resistance. Okay. So our aim is to find out the resistance R3 is changing from 0 ohm to 40 ohm. Okay, in steps of zero point 0.2 ohm, and the source voltage Vs, which is changing from 4 volt to 24 volt in steps of zero point 0.1 volt. Okay, we have to plot 3D graph of voltage across R2, okay, against both R3 variation as well as Vs variation. So you know already from the voltage division rule what would be the V2, that is voltage across R2. I will put it VR2, which is V2, that is going to be the source voltage multiplied by the resistance R2 divided by total resistance R1, R2, R3. So this is the expression that we have. As you can see, we have Vs variation as well as R3 variation both. Okay, so there will be one variation in R3, and for that, what is the value of voltage across R2 for all the values of Vs, that is 4 volt, 4.1, 4.2, 4.3 up to 24 volt. Again, you change the value of R3 to 0.2 ohm, and for that again Vs will vary. So like that it will happen. Okay. So let us try to understand this thing in MATLAB very easily. This is quite easy to simulate in, like circuit simulation. However, MATLAB can also solve it for you. Okay. So we open MATLAB. First we can clear the screen CLC. Then close all the figure if it is open. And clear all the workspace, like you have the workspace memories. So if you want, you can clear them by writing that clear. Okay. Now our aim is to define the variables, which is going to be R1, which was 1 ohm. Now R2, across which we have to find the voltage, which is 3 ohm, and R3, which is varying from 0 ohm to 40 ohm in steps of 0.2 ohm. Okay, so how it will happen? 0 ohm, and then you give the steps value 0.2 is to up to 40. If you want, you can put this 0.2 in a like variable, which is like a step, and a step equal to 0.2, and put 0 is to a step is to 40, so that if you want, you can reduce or increase the step. Okay, so that is a good method of writing the code. Similar to that, what is my Vs, the source voltage, which is varying from 4 volt to 24 volt in steps of 0.1 ohm, 0.1 volt. Okay, so 4 is to 0.1 is to 24. So this is my source voltage. So we have defined all the variables. Now if you want to know what is the length of R3, like how many values are there in R3, how many values are there in Vs. So we can put, let's say, M is equal to length of R3. So this will find the length of R3, like how many values are there in R3. Got it? If you want to see the values, you don't have to give the semicolon, so that it will appear in the command window. Okay, once you run the program. And if you don't want to see those values, then you can suppress them by putting the semicolon, which is like this. Okay, so I will see the values of M and N. Let's say N is the length of Vs, which is going to be length of Vs. Understood? So M and N we have found out. Now our aim is to vary the value of R3 and Vs, and we have to find the corresponding values of voltage across R2. So as we just now saw, that we have to find V2, which is going to be Vs multiplied by R2 divided by R1 plus R2 plus R3. So the expression that we can write down is my V2 of, let's say, M is going to be my Vs of M of R2 divided by R1 plus R2 plus R3 of mth value. So each mth value of Rm, R3, we are going to get V2 of M. Okay. As you can see here that we have the value of M and N, both are equal. If you want, you can run and see. So we have the value of M and N, which is going to be 201 and 201. You can see the value of those here. Okay. Now let us try to do that implementation using for loop. So for, let's say, a small m is equal to 1 is to m. So we are going to vary for small m is going to be 1 is to m. Now we want to find out v2 of, let's say, mth value, okay, which is going to be vs of m multiplied by r2, which is going to be the resistor across which we want to find the across which we want to find the voltage. All right. Now, what is the total resistance? R1 plus R2 plus R3 of M, because we want to find the mth value. Okay. Now we close the bracket or close the for loop by putting int. So this is how we write the program for loop. Understood? Now if you want to plot this particular graph of V2, that is voltage across R2, based on the R3 variation and Vs variation, what we are going to do? We can initiate a figure. If you have only one figure, you don't have to initiate any figure. Otherwise, you can create it. Okay. Even if you create, no problem. Now, if you want to plot 3D graph, plot 3, and then you have to give the variables, like let's say I want R3 as X, then Vs, that is source voltage, as Y, and my voltage across R2 as Z. So that will be my V2. Okay. So this is how we are going to have. Now if you see, just run it and see how the values is changing. So yes, this is my 3D graph. So as you can see, my values are changing. Okay. Now I will put the, like X label, Y label, Z label, so you will be able to identify which axis is what. Okay. So what I'll do is I'll make it little beautiful. Just put, let's say, line width I want to change. Line width to, let's say, 2. Okay. So it will become little beautiful. X label, I'll put it, let us say I want to put value of R3, right? So X label is resistance R3. You have to put it in single bracket. Okay. So single quotes you put, then it will take up. Similar to that, Y label, you are going to put it source voltage. Source voltage. Okay. So that is going to be my Vs. And Z label is going to be voltage across R2. Okay. That is, let's say, V2. Okay. So this is how you are going to see this beautifully. If you want, you can put grid on, grid on. So it will give you correct understanding. Now if you run it, see the graph is looking very beautiful. Now we have voltage across R2 which is going to change. Okay. And we have source voltage. So as you can see, my source voltage and resistance. So let me just tell you like this. Okay. So what is going to happen? My resistance R3 is changing from 0 ohm to 40 ohm. So as you can see, like my resistance is increasing, so the voltage across R2 is decreasing. So the same thing happens here also. If this resistance increases, the voltage remaining across this will decrease. Okay. So this is the good understanding. Got it? As my resistance R3 will increase, the voltage across R2 will decrease. So that is good. Next is, if you see across, like voltage, let me just show you the voltage. Okay, this is the voltage. So as my voltage is increasing, okay, my voltage across R2 is actually decreasing. Why? Because the resistance R3 is also increasing. Okay. So this is how you are going to see. Now what you can do is, your aim is to, let's say I want you to plot like this. It will be much easier to you. Okay. So you fix the value of, let's say, R1 as 1 ohm, R2 as 3 ohm, and R3 as let's say 4 ohm. Okay, and keep only Vs varying from let's say 4 volt to 24 volt. And what is the value of VR2 that you can see? Or otherwise, next question will be vary only R3 and keep Vs as 10 volt. So that is your second question. And R3 vary from 0 ohm to 40 ohm. So that is your second question. Okay. First question is vary your Vs from 4 volt to 24 volt and plot V2 versus Vs. Okay. And plot change R3 from 0 ohm to 40 ohm and plot V2 versus R3. Okay. So this will be your second question. To make you more understanding, let me just draw quickly figure. I am going to draw just like one thing. Okay. Plot. Let's say I want to just plot R3 versus Vx. So R3 changing versus my V2, that is voltage across R2. Okay. And my X label, Y label will be same. I'll just put it like this. Okay. So resistance R3 and source voltage Vs. And if you run it, you are going to see in figure 2 what is happening. The source voltage Vs, which is 3 volt at 0 ohm. Okay. And as my resistance increasing to 40 ohm, my voltage across, sorry, this is not source voltage. This was my voltage across resistance R2. So I should change it. Okay. Yes. Now I run it. So the voltage across R2, which is going to be decreasing as my R3 is increasing. Got it? That is one more. Let me just plot one more thing. I am going to plot one more figure for you. And here I am going to just vary Vs and I want to plot V2 across Vs. So what will happen? This is my source voltage. So the source voltage will be like this. So you have source voltage variation and we will be plotting voltage across R3, right? So I am making little mistake here. What we'll do is we'll make it X label as source voltage. That is my source voltage is varying in X axis, and Y label as voltage across R2. Okay, that will be my voltage across R2. Now you plot it. So as you can see, my source voltage is increasing from 4 volt to 24 volt. The voltage across R2 is actually decreasing. Why? Because the higher value of source voltage, the R3 was also increasing. If R3 is not increasing, it is constant, then you will see the voltage across R2 is actually increasing, because as you increase the voltage, as you increase this voltage, the voltage drop across this will also increase. Okay, if it is not changing, but this was changing higher, that's the reason the voltage across R2 is not increasing, it is decreasing instead. Okay, so alright guys, if you have any questions regarding this, you please put down your questions in the comment box and we shall be able to answer you out properly. Thank you so much.